show you how to calculate an inverse matrix. Now the inverse of a non-singular square matrix, non-singular means the determinant of the matrix is not 0, is denoted by a to the superscript -1, such that when we multiply an inverse by a, we get the identity matrix. Now one way to calculate this is use of the adjoint determinant formula. So the inverse is simply the adjoint of a divided by the determinant of a. Now the adjoint of a is the matrix's cofactor transpose. Okay. So we're going to calculate the adjoint of this 3 by 3 matrix by example. So for each of these elements in A, we have a cofactor. Now I showed you how to do this on a previous video on determinants. Okay, so the cofactor of the element in the first row, first column, is we block off the first row and we block off the first column, and we're left with a 2 by 2 for which we calculate the determinant. We do the same for all the other cofactors. One thing we must make sure to do is where the row number plus the column number is an odd number, we multiply the determinant by -1. Okay, so the easy way to remember this is it goes into a pattern of plus, minus, plus, minus, plus, etc. So we have 9 2 by 2 determinants to calculate. So if we do that, we get this 3 by 3 matrix here, and recall that the adjoint is the transpose of the cofactor matrix, so we transpose by swapping the rows and columns around to give us the adjoint of A. Now we're going to calculate the inverse of this matrix A. So if I just go back a couple of slides, okay, the inverse is the adjoint of A, which we just calculated, divided by the determinant. Okay, so the determinant of A, what if I expand along the top row, the first row, so we have the 1 multiplied by the determinant of the 2 by 2 matrix 5 6 5 2. Then we have 0, so I'm not going to include that. Okay, don't have to worry about that. Then we have 4 multiplied by the determinant. If we block off the first row and third column, we have 2 5 4 5. Okay, so the determinant of this matrix A is -60. Now the adjoint, which we did on the previous slide, is this matrix, so this gives us the inverse matrix A. Okay, what I've done here is I've actually left the 1 divided by 60, so this was 1 over 60 outside the matrix. We could have divided each one of these elements within the matrix by 1 over 60. You know, that's it's just personal preference. I prefer to leave the fraction outside. One thing you'll also notice is the determinant was -60. So just to tidy things up a bit, I also multiplied everything in the adjoint matrix by -1. Now we can check whether this is the correct inverse by multiplying the inverse by the matrix A, and we should get the identity matrix. So this is always a good idea to check this. So here we have the inverse A multiplied by A. So 3 by 3 multiplication of 3 by 3 matrices. So remember, we go across the row of the left matrix and down the columns of the right matrix, multiplying corresponding elements, then adding them together. So if we do this, the elements on the main diagonal are all 60. Of course, we're going to multiply by 1 over 60, so these elements are actually all 1, and this gives us the identity matrix, so we know that our inverse matrix is correct.